Well, hello, everyone. Welcome to our second webinar in the Cutting Edge Lighting Applications for Firefighters series. I am Chris Giles with FoxFury Lighting Solutions, and today we're honored to have Chief Andy Starnes with Insight Training with us. He's a 25-year veteran of the fire service and is currently a battalion chief in Charlotte, North Carolina. He is also the lead instructor and founder of Insight Training, a fire training service that focuses on thermography in firefighting. Andy's a level 2 thermography certified, so he really knows his stuff. His dedication to the fire service instruction is unparalleled. In our first webinar that we aired back in October 22nd, we talked about the science of lighting and what light is, how our eyes and minds respond to it, and why it's so important in firefighting. If you didn't get to see that webinar, I strongly suggest you do, because there was a lot of information that Andy gave us. We will post a link to that webinar along with the recording of this one as a follow-up email. Today, Andy's going to look at how light is used by different personnel of the fire crew. A chief at incident command is going to have a very different lighting needs than firefighters who are cutting vents in a roof. We'll also look at some different techniques that can be implemented by all roles of the crew to have better situational awareness and work safer so they can return home to their families after the shift. So without further delay, I'm going to pass the mic over to Andy. Andy, welcome.
Thank you, Chris. Thank you, Nikki and FoxFury family for having me and hosting this, and appreciate it. We'll make this time worthwhile for everyone. We want to provide you examples of what you can use. This is by no means a comprehensive overview of everything. It's tips and tricks and some information that we picked up and learned. And I am no means a subject matter expert in lighting. I just hang around smart people and pray it rubs off. But I have some very good experiences and hopefully some things that I can learn from you as well as we go through this. So as we get started, those of you who know me, I like to teach a little differently. So I want you to pay really close attention to this clip from the video. Who says you don't learn anything from watching romantic movies with your wife, called The Lake House? I want you to listen to what he says.
Where do you suppose this is meant to be built?
I have no idea.
Oh, but you said you liked it.
Conceptually.
Oh, come on. You know as well as I do that the light in Barcelona is quite different from the light in Tokyo. And the light in Tokyo is different from that in Prague. A truly great structure, one that is meant to stand the tests of time, never disregards its environment. A serious architect takes that into account. He knows that if he wants presence, he must consult with nature. He must be captivated by the light. Always the light. Always.
It's all about the light. Think about that statement he made. Whether you're building a building or you're working, you're playing with your kids, or just living life in general, we rely on being able to see. A profound quote I heard from a lady who was blind. They asked her experience. She said, when you wake up every day in the dark, your world is different. So we should be thankful, one, that we can see. Two, how we see is determined by a lot of things. The light itself, the environment, dawn, daytime, dusk, night, inside, outside. And for firefighters, first responders, police officers, environmental factors are a big deal, especially right now in this world. You're talking about many things, whether it could be civil unrest, it could be weather, it could be numerous things. For firefighters, it could be smoke. All of those play into how we see. And the big one that nobody likes to talk about, how we see, is how good is our eyes. As I get older, boy, do I appreciate that one. So in the first webinar, we gave you a brief overview of how your eyes work and the 3 types of vision that you have. You have photopic, scotopic, and mesopic vision. Now, photopic is your perfect lighting. You see color, you see well, you're very focused. Scotopic is more of the night vision. You're more peripheral focused. And then that middle ground, if you will, is mesopic or mesopic vision, where we try to stay, which is where we have some light, usable light, and we're able to use a combination of rods and cones in our eyes to see that. Because true scotopic vision or night vision, it takes like 30 minutes for our eyes to adjust to that. That comes from the FAA. I've recently learned that by being as what they call an already retired firefighter, or airport rescue firefighter, ARF. I learned a lot of things I didn't know about lighting thanks to the FAA. So we want to learn to stay in that mesopic range. So if we use a multi-phase lighting approach where we have different types of lights on us, different types of lights at the scene, we can use those lights in the proper context. And just like a firefighter understands, we don't pull one hose line for every fire. We don't use one light for every type of incident or situation. And our eye also has to adapt to these situations. And I've learned from the founder of FoxFury, our eye does some things in amazingly fast speed that most cameras or computers can't do. But an adaptation of light or light areas is much better when light is good in photopic vision or mesopic. However, like I said, if it's nighttime, we don't see quite as well. So you got up to 30 minutes before you can adapt. And if you've ever looked at a bright light and then shifted to dark and back and forth, there's some partial startle effect and blindness or masking where you don't see things. In this picture, you're seeing a video of a window where fire's exiting out of it, but you see the house, you see the smoke, and you see the flames. We really can't see inside of that window. We've got 3 different types of lighting here, and we're trying to figure out how to see through that. Obviously, you know, a thermal imaging camera could help with that, but we're talking about how we can use our fundamentals, in this case, lighting, to help us with that. We talked in the other webinar about lumens. A lot of times these terms can be confusing. You see people's eyes gloss over and they start to go to sleep when you start to talk about technical terms. So I found this great article by Sam Massa about equating lumens to something for all firefighters to understand, which is gallons per minute. So if you think of lumens in terms of gallons per minute, think of a hand line flowing 250 GPM. And if we have a combination nozzle and we have it set on a wide fog pattern, that's more like a floodlight. Whereas if we have it on a straight stream or we're using a smooth bore, that is more of a focused beam, right angle light, or maybe one of your side lights you place on your helmet that's getting some distance to it. So that's the amount of water that's actually hitting in any given point is actually what they call lux, if we relate it that way, because when we talk about straight streams versus combination nozzle streams, everybody wants more water getting to the seat of the fire. When we talk about lighting, lumens is how bright it is. Lux is really how effective it is and how much light's actually getting to where we need it to be. So when you look at lighting, don't just get hung up in how bright it is. Look at how far it can actually see. Is it a floodlight? Is it a focused beam? And what's the context of that use? And he continues to talk about the differences in straight stream versus combination nozzle versus a flood versus a spotlight. And you see in the pictures we have here, one from FoxFury and one from my company, you see the right angle light on the first picture, how that's going straight out in a focused beam. That has to do with the optics. Whereas we can take the same lumens and another light and spread it out, just like a fog pattern, and we're seeing more of the light around us. It's more of a floodlight, a work light if I'm working at a desk or a table. And that's just changing the optics, just like the human eye goes from a constricted iris to a dilated iris. So that makes a big difference in how we see. So when we talk about what we do on the fire ground or work in the fire department, because as a first responder or firefighter, you know, unfortunately, the fire part of our job is very, very small, but that's the one we train the most for. But we have to do a lot of other roles, a lot of other things. So we need lighting for all of those different things. But what people don't think about is, okay, if I'm a firefighter, I need different lighting than a driver, as Chris said. And as an incident commander, I need different lighting. And I need to know what those lights are and how they're used and how I can apply that before I show up. Like say, I want to have it and not need it. I already know what I need and set it up appropriately. So we're considering what we call a tactical approach to lighting. So we're going to talk about these 3 roles in specifically: incident commanders, drivers or engineers or operators, pump apparatus operators, firefighters, and EMTs. Those of you who drive fire trucks, you're going to love this because I'm going to start with you. You're the most important person in this scenario. Why? Because when we go to a call, typically, you know, the battalion chief may get there first, but typically the driver operator is the one getting the fire truck, whether an engine or ladder or rescue, there first. And when they get there, what does that operator got to do? They have to consider something Robert Avsek says, a new tactical benchmark. Yeah, when you come off the truck, you got to be stretching lines, doing your tactical benchmarks or your priorities, whether you're starting a search, doing an aggressive fire attack, whatever it may be. But if I can't see, then I can't do my job effectively. So he says it, or puts it very well. If we can't see the risk, we can't address the risk. So when I talk about teaching thermal imaging, I always tell firefighters, I want you to see the heat versus feeling the heat. Because the military uses everything they got to go get the bad guy. Why are we not using everything we have to help the good guy? In this case, lighting up a stairwell so the firefighters can see to get up that stairwell and work is, something you may consider simple and not a big deal. But if that driver doesn't set that up in the process of setting up the incident, and you come down and miss a step and fall down the stairs and end up, like we said in the first webinar, between 54% of injuries are outside, 46% are inside, and a third of those injuries result in a loss of work time. With COVID and everything else going on, do you want to be out of work even more, quarantines and all that? No, simply lighting it up so we can see. So the order of importance in lighting up the scene should be moved up, in my opinion, and several authors I read, that illuminating the scene should be the first priority we have. So when you're driving a fire apparatus, how could you do that? You could simply start lighting it up as you pull in. You could use your brow lighting, you could do your side lighting, you could do a lot of things. And a good friend and mentor of mine, Lieutenant Michael Daly, who's also president of the organization I belong to, Project Kill the Flashover, just wrote an article in Firehouse about nighttime operations on the fire ground. And what he says is pretty profound. He talks about when we have a fire or an incident, there's very little thought of that incident scheduling it when it's convenient for us. But when we go to these incidents, how have we trained for those? 99% of us, I would say, train during the daytime. We train for fires, EMS, extrication, high angle, whatever it is, we train in well-lit conditions. But that's not the environment we work in. So everybody complains about not having real life fire ground situations, like using real fuels and adequate fires for us to train firefighters how to fight them. But nobody's talking about, hey, maybe we should do this operation in the dark and show how we need to set up these lights, because if you did that, maybe you would see this incident differently and perform better when the incident actually occurs. Because he says it best, to truly be best prepared for these incidents, training should occur during evening hours, because I'll bet you we won't forget to turn the lights on if we do this on a regular basis, and it becomes more of a priority. Now, there's numerous types of lighting out there. Can't cover them all, but no, at first we think about when we're pulling up, we already have apparatus mounted light on most of the fire trucks today. We also have tripods or portable lights. We have personal lights, which every firefighter should carry at least one light. I'm a believer in redundancy, so have at least two, because one's going to fail, and having the other one for a different purpose. You also have all the other lights that they're putting on us. We look like a Christmas tree. We've got our SCBAs, we've got our lapel mics that have lights in them. Everything's got lights in it now. We're gonna be lit up. When you think about passive lighting too, that nobody talks about, your reflective striping on your gear, on your air packs, your helmets, you're designed to stand out. Okay. So when we illuminate things, we need someone to tell us why we need to illuminate it. So bear with me. I have an 11-year-old, so I like to tell you why we need to illuminate it and give you some presents here.
La la la. Illumination. 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 Oops.
All firefighters break stuff. I thought that was neat that he broke something. So we got to illuminate with passion, right? When we show up, they see us coming, right? Got all our red lights on, our strobes. We need to announce that we're there and be able to see the incident. They need to see us. So we need to light up the scene. How do we do that? When the engineer is driving up, have you ever thought about turning on the brow light and the side lights before you get to the actual scene? I'm not talking about while you're on the road blinding cars, but as you're approaching, that order of arrival, that first due apparatus can see a lot of things that we wouldn't normally be able to see. How many times we missed a hydrant? If you had to do water drafting in rural operations, you couldn't see the pond. Would you like to pull up and park underneath this power pole? And think about how many times you see in the news that we are complaining about people blocking fire hydrants or running over large diameter hose. But then you go on these larger second alarm, third alarm, mutual aid incidents, and there's been documented reports of fire trucks pulling in and running over the supply hose because they didn't see it. So why don't we light it up as we're approaching and slow down and see what we need to see? This incident here is a great example of photo credit from Newsbreak, where these 30 teenagers decided they wanted to go explore a cave in the middle of the night. Just this rescue pulling up and the ambulance on the side, they illuminated the entire side or hillside so they could go in and get them. We want to create a radius of light from our apparatus towards the incident, kind of rain down on it, not necessarily a torch, giant photon beam blinding them. We want it to be able to rain down on it so they can see the incident and not be blinded when they look back to the chief or the apparatus operator. They say you should light up 6 sides of the incident. Well, what is that? All 4 sides, the interior, and the roof. Now, you may be working above, like on a cell phone tower, on a high angle rescue. You may be working down below in an embankment or confined space. Still, you need to light it up as much as possible. So here's a challenge for you driver apparatus operators, though. Everybody else is training on how fast they can pull a hand line and deploy it, how fast they can force a door. How about this? The next time you do those drills, have the driver pull up, do what they have to do to get everything set up. But the first thing they should do is be lighting up the side of the scene or the front of the scene. And then how fast can they get your portable lights set up in areas that are critical for that fire ground success or that incident success? How about you start drilling on that? Because, my old driver used to say, you got 2 minutes from the time the park brake's set and you're getting wet, I'm charging the line. Well, that's fine, but I want to be able to see. So if our truck has all these lights, let's teach our apparatus operators to turn them on as they arrive, and let's teach them to set up the other lights that are probably not as commonly used until later in the incident. Let's use them early and often. Light up all 4 corners, Alpha, Bravo, Charlie, Delta, or 1, 2, 3, 4, depending on where you're from, whether you're from the rest of the country or New York, because they use 1, 2, 3, 4. So when we pull up, we ought to also think about, once that's done, we need to light up the interior and exit lighting. That's where those portable lights really come into play. Some type of tripod light, smaller light, battery powered lights that you can set them up. Now, I will caution you, when you set these up, make sure you're illuminating or lighting up that area, not directly, but kind of in an angle. Because a lot of times when we focus directly at it and put it maybe where everyone's walking, that bright light's also masking what's around it. Like if you got it on the sidewalk, I found out this the hard way, and I'm walking towards the light. I see the side of the building. I can't see past the light because it's so bright. If I hadn't slowed down, as soon as I passed that light, 3 more feet was a 5-foot drop off. So we make sure you're lighting up the incident and any potential hazards where nobody can get hurt. Using brow lights or tripod lights in these incidents are really valuable, because you're talking about working down an embankment where cars crash, because cars don't crash in perfect places. They end up in odd places, in buildings, down embankments, in rivers. We need to be able to get the light to them. If you have a tower lighting, that's great. That can help you with that. But we want to make sure that it's raining down on them indirectly, not as in this case where they have it set at your eyeball height and you're looking back and you're blinded by it. So I like the concept of indirect lighting. If you have side lights on your apparatus, whether they're removable or mounted on there, they're quick, powerful, extremely important. Boom, turn it on. I've got the side lit up. Takes seconds to do. That's a great way to go ahead and get the scene lit up and start there. If you have the tower lightings like these that come off the truck, that's great, but a lot of departments don't have the funding to buy such expensive equipment. But these side lights can be engaged while driving. We can detect and recognize critical scene information, things that we may not normally see. What if you got cars down an embankment and you're looking for ejected patients? You turn it on as you're pulling up and you realize the patient's right there, right next to you, when the vehicle's 50 feet away. There's been documented cases of first responders driving over victims at incidents on the highway. Don't you want to be able to see that before you run over somebody? So it allows us to immediately begin our work and better assess the scene. One thing that I didn't really consider until the last few years is the drivers opening up all the compartments around the apparatus, because now they have rope lighting in there, which allows them to illuminate all the way around the sides of the apparatus for work. This is more of a soft lighting. It helps them see better. If they are working right next to the incident on the roadway, they just turn their emergency lights off and turn them on hazards. If you're blocking the roadway, you want to use directional lighting and a low power setting, because they've proven The brighter lights at night on our emergency vehicles are actually drawing impaired drivers toward us. Remember in the first webinar, we talked about phototaxis. That's actually drawing them to it. And when we're setting up to work in long period durations, maybe overhaul, you got crime scene, you've got different things you're helping the police with. This is one FoxFury Nomad light, the same as a tripod light, if you will, lighting up the whole side of this incident where the wildfires in California. One light. Now, if you're like me, I like to work smarter, not harder. Why would I want to deploy multiple lights when I can set up one light that's going to last 12 hours and can do the job? I like to work smarter, not harder as I get older. Another thing departments that can consider when they're talking about budgeting, lighting can be expensive, especially if you're putting on apparatus. You look at just that little spinny little, what I call the Christmas tree spinning light they put on the front of fire trucks now. That's like a $5,000 option. You want to put a tower light on the top of your truck, that's pretty expensive too. What about a smaller, less expensive drone with one of FoxFury's drone lights on it and using it to illuminate, as the minions taught us there, the scene where we can't really reach it? We could get that there really quickly, light up that area for the first responders to work, can keep it lit up for 15 to 20 minutes while we're setting up additional lighting. It's a very cost-effective approach if you're already using drones. Think about that. The lights on those things are amazingly powerful. I was shocked, witnessed some in the training recently, of how bright they are and what they can really do. Plus, they can provide video feed back to the incident commander, which is even more important. So leading into that, if you are the IC, the incident commander, where you're the first due company officer or battalion chief, or however it works in your organization, you need to think about lighting from a different aspect. They've got to light up the scene, but you need task lighting and situational awareness lighting. You also need to think about where you're going to be located as an incident commander. You need to be close enough to see the big picture, but not so close that you get tunnel vision, all the noise gets in the way, and you get task fixation and you're tempted to get involved, because you got to stay in your lane or know your role. But decision-making requires data. And that data means I have to be far enough back to see the big picture. My friend and mentor, Chief Lamb, said, if you think you're far enough back, take 15 more steps. And my dad taught me, once you do your 360 and you've got your information, get your butt inside that command vehicle or buggy and roll up the windows. Because the minute you stay outside where you have noise and all these things competing for your attention, despite what we may think, we can't keep up with all that information. We will miss something. So whether you're an inside command vehicle or outside command vehicle incident commander, we're going to show you how you can use that lighting. So if you're like my friend, Chief Matt Tobias here, a good friend from Harrisonburg, Virginia, has a pretty cool setup on the back of their Tahoes or Suburbans. They've got the pull-out command board. You can have lighting above there. This type of command post, he could set it up far enough back to see. He's got his radio, but we don't need super bright lights right there. We need low-level lighting, such as the scout light that FoxFury sells, or a small one of those little flexible desk lights to illuminate task boards, radios, and work areas. And that lighting should not interfere with his or her view of looking at the big picture of the incident. Because if I've got two really bright lights next to you, it can mask his or her view looking forward. They need to be able to see that. And that goes whether you're sitting inside or outside the vehicle. So think about that. And the only way you're going to know this, ladies and gentlemen, is if you get out and see what you can see day, dusk, evening, nighttime. See the difference. You'll be surprised. I always tell people when they buy thermal imaging cameras, don't buy it based on what it does in the day room. You better go test it in a fire. Well, you better go test these lighting scenarios out in those actual environments so you can see what you see. If you're that first due company officer and you're doing your hot lap, or you're, like we call it, the tactical 360, you're walking around the building and seeing what kind of incident you got and gathering information for your incident action plan, you need lighting too. I'm clumsy enough in the daytime. Now you're going to put me in dark or poor lighting conditions. I'm going to step in a hole. I'm going to miss a step, fall somewhere, step on something I shouldn't. So I need to have lighting. I can have helmet lights, right angle lights, small lights, whatever you want. But something as simple as putting a light on your radio strap, like the FoxFury Scout light works really well. You can clip it to your coat, mount it to your helmet, or all the above. I like all the above because never fails. No matter what you do, you're going to have a light go bad or the batteries are going to go bad. So what's your plan B? Especially if you're this person in charge and you're telling everybody else, you need to carry a flashlight. And they look over at you and you got 3 flashlights and none of them are working or none of them are on. So be a good example. Task lighting for the incident commander can vary, but if you're working on one of those command boards or you're sitting inside the vehicle, you can use different types of lighting. But this is a small, simple example we used where we took 2 of the scout lights, clipped it to the stairs. We set up our boards at 6 o'clock in the morning, and we're able to do that. You also have lighting you have to think about that comes from your radios, computers, all that. I don't want a super bright light inside my vehicle. If you don't believe me, the next time you're going on a road trip with your family, let your kid turn on that back interior light when you're trying to drive down the interstate or back out of the driveway and see how well you can see. It don't work because that light is competing with your eye's ability to focus on the darker area, and you get that masking effect and you're going to hit something. And if you hit your own car, by the way, you can't file an insurance claim against yourself. Just a little tidbit there. Not that I've ever done that. Ask my wife about it. Low level lighting doesn't interfere with night vision. Just like if you look at your dash lighting, it's low LEDs, allows you to look out like this picture from the crash truck looking out towards the airport. You can see the gauges, you can see the computer, you can still focus on what you need to focus on. What we're trying to tell you is you need to have just enough light to do your work and more light outside to see the event. This is a crude little diagram I did. I'm not a graphic designer, so don't shoot me. But we have our building, we have our simulated fire, we have all 4 corners lit up, whether we're using apparatus lighting or portable lighting, and we've got the fire chief in his cool vintage car back way up on this side over here, the Delta exposure, far enough back where he or she is not in the way, just like we fuss at our police officer brothers and sisters for getting in the way. Fire chief can get in the way, right? Well, they say chaos, the definition is chief has arrived on scene. So let's not cause chaos. Let's be out of the way so we can see the big picture. And if you see an area or a gap in the lighting, talk to that particular role and have them address it. But make sure it's lit up so those firefighters can do that. This is a great position for the safety officer. If you're blessed to have a safety officer in your department, have them make sure it's lit up, especially if they're working in treacherous conditions, ravines, down embankments, bad places, right? And the other thing we talk about is big incidents. This is a great picture from FoxFury looking down from a drone at a larger scale incident. You got to think about a larger scale incident is going to go past 12 hours. And if you're like on the East Coast, it gets dark here at 4:30 now. What's your plan for that lighting? Is it permanent lighting? Is it portable lighting? How are you going to do that? Tripod and portable lights are essential because once my fire trucks are set and I got 5-inch hook to them or the ladder up in the air, I'm not going to be able to move that thing. So I need to be able to move the lights where I need them, just like in this public information briefing that we had after a fatal fire at my department. We're able to light that up for the firefighters, for the news, and see what we need to see. That also goes for overhaul, investigations, whatever it is. It's flexible, it's movable, because we deal with dynamic incidents. No incident is the same, no need is the same, no house is the same. Therefore, the lighting should be adaptable and customized to that context. The thing you got to think about, though, what kind of light am I using? Is it going to last? Is it electrical, battery powered, or gas powered? If you hadn't noticed, they're going away from gas power. It's more electrical and battery powered. You got to watch out for carbon monoxide issues when you're using battery powered or generator. Where is that going? How close is it to the area you're working? If I'm using battery powered lights, do I know how long they're going to last? Do I have a plan B to swap those lights out with other batteries or charged lights for that? If I'm using the command post or the apparatus lighting, those are permanent there. But if I'm there more than 12, 14 hours, who's fueling up that truck too? Because I don't know about you, but our trucks get 1.2 gallons per mile, not miles per gallon. So make sure you got that plan B in effect too. So let's talk about the next part. This is the fun one. Firefighters have the most challenging part when we talk about lighting. Why? You could be anywhere. You could be inside of a car working. You could be taking care of a newborn baby. You could be changing a tire in the back parking lot for somebody. You could do anything. We are the ultimate civil servant when it comes to when everybody calls or they call everybody else. They don't know who to call. Who do they call? They call us to fix their problem. So you need adaptable lighting that you can improvise for any situation. The reason it's most challenging is your position is dynamic. So therefore your lighting needs are dynamic. Therefore more than one approach is needed. Like I said in the beginning, you don't pull an 1 3/4 hand line for every fire. You pull the right line for the right fire based on the conditions. As my friend Kyle Romigas says, conditions dictate tactics. Or John Norman says, let circumstances dictate procedures. Well, that should also apply to tools that goes within those procedures. So dynamic examples. For example, this is my personal favorite. Your sleep, comfortable bedroom, 2 in the morning, and that dreaded turkey gobbler noise goes off, doo, 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 and you have a heart attack because it woke you up from a dead sleep, and you go from dark to light. If you haven't noticed, they're starting to put red lights up there instead of white in stations that are doing the sleep studies. I'll talk about that in a little bit. So I go from a dark bedroom to a dimly lit cab of a fire apparatus to possibly a brightly lit scene. How fast do I have to change and adapt to that? So when I talk about staying in that mesopic range, if you have a dull lighting coming out of the bedroom, the red lighting in the cab, and then you're stepping out into a bright light, it's not going to be quite as hard on your eyes, especially us older individuals, as it is on those who have good eyes. So an example is using something like this that has that red lighting. And if you hadn't read this, I encourage you to look at it. Blue light has been implicated in keeping us awake at night. What is blue light? It's a combination of that white light that comes from what? Anybody recognize this little device? More people look at this at night in the dark, and it affects their sleep. So if I have a red light waking me up, I have the red light on there, and I have the red lights in the cabs, I'm gradually adjusting to that environment. So think about that and do some homework. I can send you the articles and the works cited page here at the end. It allows you to adjust and see a little bit better. And when we talk about lighting as a firefighter, we need to think about that we always need lighting day or night. These are the exact same task, but 2 different lighting needs. We're going to vent the roof during the daytime. Now we can see when we come off that ladder, but how well can we see depends on a lot of things. Is our mask fogged up? Is it raining? Is it a beautiful day? The other thing they don't think about is that bright light from that fire can actually hide issues like holes in the roof. You could miss a step. There's lots of things you could miss. Whereas you look at this lower picture, have you noticed newer ladder companies are putting LED rope lighting up? So if I'm coming off this ladder and I'm about to step on that roof and it's got a 3-foot parapet wall, I need to have my lights on as I'm going up, not wait till I'm at the end to turn them on. Whether you realize it or not, there's an issue in the fire service with lighting. And here's why. Every training I've gone to that doesn't involve live fire, where they're using fake smoke or just blacking out the area, they'll tell firefighters you can't use your flashlights. You know, we're indoctrinating them not to use them, because I've seen more firefighters carrying flashlights, including me, and not turning them on. It doesn't do any good. When you step off that ladder, this is a picture at night of where I was assigned for several years, Station 2. They're about to get up and come off of this roof after cutting the hole. That's a really bright light from that flame, and you can miss a step really easily. So we need that light, that personal light, whether it's a helmet light, a right angle light, or a combination, your box light, so you can see, guide your path, guide your steps. And more importantly, if you're the company officer, you're not the first one off the roof. You're the last one off the roof, because you should be lighting up that path for them. Okay. Your job is to watch over them. I don't have a problem with the company officer being first off the ladder onto the roof to make sure it's safe, but the company officer should be the last one off the roof, providing that ambient lighting so they can see and making sure all firefighters got off the roof, out of the building. And that's why the company officer should set the example by having good lighting. And when we're transitioning, this is a daylight example. We're going from bright light outside in the sunshine, moving up the stairs, just to the first landing. We're already in a dark room, and firefighters are not carrying lights. It is extremely important that we carry our tools. How's it going to look when we really needed that light and you got to the top of the stairs, made the push, and there was a victim in the far corner of the landing, and it could have been easily spotted if we just had our lights on and scanned the landing. Think about this. You're running towards the fire. They're running away from the fire. Where could they be? Make sure you're looking as you're going and using your lighting. And those dynamic environments obviously require different lights, but these are just a few examples of my gear at a recent training event. You got the light coming off the lapel light. That's a built-in light. You got my FoxFury BTS hybrid there. That's a rechargeable right angle light. We have box lights. You have passive lighting systems, which are reflective stickers or striping. You may have even more built-in lights to your SCBAs, mask, hoods, these little gauges on the side of your air pack that tell you how much air you got. Those glow. It's more of a passive lighting system. You got the blinking lights from when your pass device is going off or ramping up. Like I said, we look like a Christmas tree. So when I go in, I believe in at least a two-phase lighting approach for the firefighters. And the reason I believe in that is because you need to be able to see what you're wanting to get to and see where you're at. And here's the problem. That doesn't mean all those lights need to be turned on at one time. Because those of you who've been around long enough know that once you go into a lot of smoke, it creates a wall effect. So I want to use the right light at the right time in the right context. So if I'm in a lot of smoke and I'm trying to look farther away, I need a more focused beam. If I'm working directly in front of me, like down an embankment or in a dark spot, I can use my peripheral lighting of my command helmet light, like I use here in Instructor Joey Bax's helmet on the lower picture. So make sure you're using the right light for the right context. You can carry as many lights as you want, but also think about this being an entanglement hazard. I want lights on me, but I don't want them to be dragging and stretching, and everywhere we crawl, we're going to get hooked on something. So my helmet light is not sticking off to the side. It's not creating an issue. My right angle light's pretty close to my coat. A very smarter man than me, Brian Brush, recommends that you flip that upside down. So it allows you to scan easier and lower. I think that's a great tip. You can identify objects and read smoke, which we talk about. And that box light, if you use like a seatbelt strap and you have it clipped underneath your SCBA waist belt, it's going to stay in position pointing alongside of your leg. And if you crawl with your right knee down, left leg up, it's illuminating that floor around you. So that's your situational awareness, being able to see where you're at, see where the victim might be. You can use it to mark the door when you're guiding firefighters. If you're at the door and they're searching, they can see that light because you're down low. Just like if you go into an airplane or any newer building, they're putting exit lights down low. Why? Because they finally figured out that that's where the visibility is. And here's that issue I said a little bit ago. Watch these firefighters go into this training event. Tell me how many flashlights you see. None. And one of them is my guys. So you see the light from the tick? I got GoPros and all kind of fancy different ones, but there's lights on these firefighters that are not turned on. If you don't believe this is a problem, as they say, we need to open our eyes and watch. Firefighters are being trained not to use their flashlights. Turn them on, carry them, okay? And if, whether you believe it or not, you're only going to see so far with a light, but so far could be just enough to pick up that foot or that hand or that victim or that area that could get you in trouble if you didn't see it. So my recommendation is you have a multi-phase light approach that allows you to do different things. That helmet light for me is like immediate surroundings. If I have the side slide light, which is like a pointed helmet light, a focus beam, wherever my head goes, the light goes looking at a target far off. A right angle light is more flexible. I can move it. I can scan underneath beds. I can look at different things. I can guide streams with it. And the box light is really important in general because the majority of firefighters carry one because I can use it for looking for live fire layout, marking doors. I can use it for any number of things. It's limited to your imagination. Point being, have a system that works for you. Make sure you can do it systematically, consistently, and carry it. And do me a favor, when you check your stuff in the morning, check your lights. If it's been a little while, change the batteries. Majority of departments provide batteries now. You can change them at work. And not just any old light will do either, because this is the thing that gets me upset is firefighters will spend money on pro bars, leather helmets, and all this, but they won't buy a thermal imaging camera and they won't buy a good flashlight. You tell me which flashlight shows up better, the cheaper one or the higher quality one as it comes out this door. Get what you pay for right there. That's a very inexpensive light. And that's a higher performing light. Think about this. We spend more money on things we don't need, but a little bit of quality and time in the things you really need, which is your ability to see. So as a firefighter, your ability to see is limited today's world. Why? Think about the environments we function in now. We're looking at lightweight construction, high heat release rate fuels, that lead to ventilation limited fires, which means we have burned up most of the available oxygen and we're in an environment that has limited to next to zero visibility. If you're not following it, look at firefighterrescuesurvey.com and you will realize that almost 75% of all victims are found in limited or zero visibility. This is the world we work in and live in. It is therefore paramount and critical that you have a good light. I'm a big believer in having the light and the thermal imaging camera, but make sure everything is charged and turned on. Is your light on? What's your backup plan? A lot of departments too have a problem where they won't let you use anything but city issued. Are you able to have more than one light? What's your backup plan, and do you scan low? This is probably the second biggest issue not to carrying the light is firefighters standing up and trying to scan with any flashlight or any thermal imaging camera in an exhaust with turbulent smoke and moisture coming at them, and they complain about not being able to see. That's like stepping out into a windstorm and complaining about something getting blown into your eyeball. You're asking for. Where is the air cooler and slower typically? Down low, unless we're in a basement or in another issue. So make sure that you're getting in the right area so you can see better. Just as in this video, you see this firefighter watching the fire grow. We can read smoke. We can identify the flow path, and we need to know, is it a bidirectional flow, which means an intake down low and exhaust up top? Is it a unidirectional flow path, which is an intake on one end and an exhaust on the other, which more firefighters have died in that than any other type of event? We can read the smoke to lead us to the fire, and we can read the smoke to find our way out. So I'm a big believer in a thermal imaging camera. Y'all know that. But I'm a bigger believer in fundamentals. And fundamentals are your skills of knowing how to perform in these situations and using things that everyone carries and can afford, which is a flashlight. Read the smoke, read the building, and find your way out. You need to know where the smoke is moving and why. And that tells you whether you're on plane, off plane, like you're above it or below it, if the stream is flowing and how that affects that. And we're going to show you examples of that. And look how quickly this changes. The neutral plane's collapsed, and you can see the smoke conditions changing in the room he's in. He's starting to lose visibility. Do you think he needs a good flashlight? Yeah, absolutely. So let's look at every class has what they call a disclaimer. If you are in a building and it's sealed up, you're above the fire or in a room where there's stagnant smoke, you can actually have very little movement, and it's very difficult to read smoke. So you should do what to stay oriented? You have different ways of doing that. Stay on a hose line, a wall, designated adult. This is a quick little video using fake smoke to show you, even when we're close to an exit with the best light we can buy, we still may not be able to see. All right, zero visibility, flashlight, still don't see anything. I'm on a wall. I have to follow the wall to find my way. This is why you need the camera. Todd's 8 feet away from me. It's the power of using all of your tools. So the point is, be a thinking firefighter. Don't be a checklist one, okay? And when I talked about those different types of intakes and exhaust or flow paths, this is my father's work, an example of an intake, an exhaust, and a bidirectional flow. And that area in the middle is known as a neutral plane or neutral zone. You've heard people call it interface layer. It's actually where the two areas meet, and that area is supposedly a neutral area of pressure, and that's where things mix, and that's where bad things happen. So if that thing is descending, that is not good, especially if it's already to the floor. Just remember that when you're moving through an environment, okay? This is an example of a bidirectional flow from a video credit from Jay Bonifield, one of the best nozzle guys I know, and how quickly a bidirectional flow can go bad, and why we need both, all three really, our training, our tools, and technology to identify this and do something about it. Watch very quickly how this neutral plane is already below 50%, which we can identify with the flashlight. We can see the heat with the camera, and that we need to mitigate it. I'm not saying don't go, but we use our tools and our technology and training and tactics to address this. Right here, we should say, we need to open up and get rid of this. This is bad. This is flowing past our head. Neutral plane's at 50%, smoke's moving fast. I got lots of heat going past me. That's an exhaust. So they do open up, start knocking it back, and they start to seal the door. So that's important that we do something about it, not just let it keep happening to us. As Dennis Laguerre says, we need to send bombs or bullets down range. Don't just sit there and take a beating. You realize you're crawling in an oven, a convection oven. And what I want you to be cautious of is something called a unidirectional flow path, especially if it's an intake on one side and it's an all exhaust coming towards you. Think about that. You're crawling in an exhaust. What's transferring to you in that exhaust? Energy. Are you doing any good by not cooling that environment? No. Watch this great video from Jay again, where it's an intake, all drawing in, and how quickly it becomes an exhaust. See the smoke moving forward, drawing into the door. You see through the thermal imaging camera, heat coming out. All of a sudden there's a pause, it lifts, and then you have ignition. And when that happens, we're already behind the 8 ball. The nozzle should have already been opened. We don't wait till we see orange. We see heat, we erase heat. We were taught not to crawl past fire. I'm going to teach you to use everything you got, not to crawl past heat or superheated fuels, and read the smoke too with the camera, with the flashlight, with your training, and understand that moving things, velocity, as Dave Dotson taught us, is not a good thing. Velocity indicates growth. Remember that when you're moving towards the seat of the fire. And when I use something like the FoxFury right angle light, gives me a focus distance beam, it allows me to look for things that we should already be looking for. Life, victim location, fire, where's the fire, location and severity, and then layout, building configuration, and furniture orientation. If I take that right angle light, and when I do all that, and then I drop it down low and turn it 90 degrees and point it up, and I look at the smoke, and the smoke up top is moving past me out, and the smoke down low, the air movement is moving in. I'm in a bidirectional flow. I can follow that intake to what? Directly to the seat of the fire. This video we had when we did in Fairfax, you can see the effects of us moving into that smoke, flowing water, and using the flashlight in addition to the camera to guide the stream. Right there, he's telling him where he wants to put the water. He's also going to use his light. He cools it down where they can move. They move up. Now they're inside the fire environment. Watch the smoke moving past them, and watch how we use the light to guide the nozzle as well. He said it's rolling pretty good out that Charlie wall, which he knows that's the wall he's on. So he knows he needs to cool that more sufficiently. As long as that nozzle's open, where's that smoke going? Away from him. He's creating a pressure front. As we move forward, right now we're one room away from the fire, pretty much zero visibility. We can see some embers. Watch what we use the right angle light to help him guide it. I hear guys all the time say, flow up, down, left, and right. And I end up getting hit in the head with a straight stream because up, down, left, or right, and zero visibility gets us in trouble. I show them with the light. I put my hand on the shoulder and say, flow from water from 9 o'clock to 3 o'clock. This is a good way of doing that.
Fire room's one room away. Okay, you just move just past that once you get it knocked back, and then rotate off the nozzle and let somebody else do it, okay? All right, let him show you where he wants to put it. All right, so start the ceiling of the 12 spots. Okay. Nice little C-pad down.
What do you see right there? You see my flashlight? You see the stream going where I tell him to put it. And you encourage them. That's pretty. Good job. Don't beat them up when they're doing a good job. So reading smoke is important. Everybody's taught to read smoke from the exterior. I don't hear much of them reading the interior. What light you choose to do, that's up to you, but I would use more of a focused beam light, and I'm looking for speed of smoke, direction of travel, difference between intake and exhaust, and I want to continually reassess for changing conditions, because those of you who are well studied in this understand that the environment we work in changes fast. So we want to make sure we're paying attention. This is an example of smoke on the same level, same plane, one-story ranch house. You watch as this grows, we end up with an intake down low, an exhaust up top. It's nothing dramatic, but you can see where it's drawing air in, and you can find the fire by following the intake. fire and smoke moving across the ceiling, moving down the hallway where this camera is positioned. You're seeing the smoke descend. You see the air intake down low. You've got fast moving smoke, heat coming across the ceiling. It moves from high pressure to low pressure, or hot to cold. It's hot in this room. It's moving back towards the opposite area where it's colder. And that neutral plane is lowering and descending. We still have, look at this, we still have clean air down here relatively. And then we have nasty stuff up top. We can use our light to diagnose that. So we can assess these conditions as we move from compartment to compartment. Don't just do it at the front door. Do it as you move from room to room, and continually check if you're sitting there for a second. This is a more clear video showing you where you can see it a little bit better. You can watch the movement, the exhaust, intake, and the neutral plane. This is just one burn barrel. Look how it's spiraling down towards it. You've got an intake down low, an exhaust up top, and watch it moving away from it. And when I go to the front door and open the front door, watch what you see at the front door. Right here, I can see the smoke coming out the top and the air going in down low. That's a bidirectional flow. I can use that to find the fire, even if I don't have a thermal imaging camera. So when I'm looking at this intake and exhaust, look at the difference in this one. This is almost full exhaust. The intake is down low. That's not good. We don't want the neutral plane that low.
Steal some of your wet hay. Rock on, bro.
See how low he's having to get to scan? That's almost a full exhaust. We don't want to crawl in a full exhaust. So if we're moving in that, we need to be doing something about it. And that's where the nozzle comes into play, with it's fully open, not half bail either. And this is another example of sometimes things are not how we see them. This is a window on one side open, window on the other. We're clearing the smoke out. You would think it's just blowing straight across. And I have what's known as an anemometer. You can watch the speed of this thing. When I first put it at the top of the window, it starts moving, then it stops. And then when I put it down low, it speeds up. It's actually moving from up high and down low and blowing out the bottom half of that window. You can see it's coming in that window. So it's coming towards me. You can hear the wind. See it moving initially pretty good. And then all of a sudden that anemometer, the fan will just stop. You're like, wait a minute, why is it slowing down? What's it doing that for? Let me put it down low and see what happens. So now it's blowing past me. So each building, wind conditions, windward, leeward side, that all makes a difference. Like I said, every fire is different. You got weather factors, environmental factors. This is a demonstration using the hydrovent nozzle, where you put the nozzle in the window, it puts 100 gallons a minute at the ceiling, pulls 100 GPM out, pulling the smoke and gases away from the victim. When we turn this thing on, I want you to watch all the heat and smoke be drawn away, and how you could use your flashlight to read this. This is a pretty nice fire, because this is for demonstration purposes. This is actual furniture used, not a training event. See the smoke and flames coming across the top. Got a bidirectional flow at Thomas's head, 50% of the door space. You can clearly see the base of the fire by following the intake. They're going to let this monster come on out, come on out. Thomas is wearing one of our FoxFury lights. He's using a camera to see in there. Tells him to turn the nozzle on. When he turns the nozzle on, you'll hear it. Watch what happens to our fire and our air track, or our flow path. Nozzle's on. Now the air intake is drawing in. We don't have an exhaust. We got a full intake drawing everything away from us. Watch as they move in. You see the smoke tunneling and moving towards that exhaust point. Temperatures drop to below 200 degrees. See how fast the smoke and gases are moving away from us, being pulled out the window. Same concept as using an outside vent man or hydraulic ventilation. But that's how you can tell where it's going. So when we're reading smoke, I want you to think about, it matters where you are. Are you on the same plane, same level? Is the fire below you, or is it above you? And how does that affect the movement or air or smoke, or i.e. the flow path? In this example, we're opening the door there's a staircase to our left. That makes a big difference. So this training video here we shot in Harrisonburg, you're going to see the smoke moving up the stairs and the effects of opening the door to the fire room and closing the door. Not as much dramatic as it is as you watch that smoke and the movement and where it's going.
All right. If you're truly watching the stairwell, come in and close the door. We gotta watch for a couple things. Right?
Smoke is moving up the stairs.
Right? So we watch to make sure it's not coming this way. Right? And occasionally we're gonna make sure it's not breaking through to where they are. It's gonna run in points, right?
Their assignment is to hold the stairwell while the crew is searching above. They're protecting the egress path.
So a lot of times guys won't look at the stairs themselves. They don't look straight over their head. Look at the air moving.
See the air moving?
Moving towards the door, right? Watch. Sit right here. Watch this hallway when I open the door.
I'm going to go down the hallway and open the door to the fire room. What they get to see is the amount of heat, smoke, and gases moving past them. Notice what happened to the clarity of my light and my helmet cam. When I open that doorway, now I got all that smoke and heat moving down there. I can't see a whole lot, can I?
You see it coming down the hallway?
So they're able to see it coming to them.
So you know, if you see that, something's changed, right? So just little cues and clues where I'm using more than my eyes.
Notice how the smoke's moving past them towards the exit and up the
I'm
stairs.
watching the smoke just like you can see on the light moving. I'm also using this to help.
So point being is I want you to pay attention. Too many times we get in there and we're not paying attention. We're focused on one singular task. You're in an environment that's constantly changing based on ventilation, geometry and configuration of fuels, and a lot of variables we can't control. We can control how we behave in that environment and control the temperature, we can control the air. And you can watch it and tell where it's going and what it's doing. And that comes with training, education, and knowledge. And a good flashlight, by the way, too. So when we talk about fire above us, an example, this 3-story apartment where the fire's in the attic here, obviously, we open the door, we watch the smoke movement. If it's up the stairs or above us, the smoke's going to lift, move, and spiral towards the stairwell. Follow the intake. If you learn anything, watch intakes down low, and it will lead you to the source. If you got a chance to take Scott Corrigan's webinar they just did, he's big on telling you to hunt the intakes. That's great advice, because the intake is drawing air into what? Towards the base of the fire. Layman proved in the 50s, if we put droplets of water in the air intake, it'll go places our stream won't reach. By reading it, we can actually follow it. And if you're one of my truck company brothers and sisters that have to work on the roof, please make sure you're not just relying on the light from the aerial. Because in this example, if I just paid attention to that, as soon as you got to the end here, that's a 60-foot drop. What you don't see is they're stepping on a roof that has a metal skeleton, and every 8 feet is a gap. And in between that gap is nothing but tin and foam. If they don't use their portable light to see where they need to step on that actual support member, they're going to fall. So personal lighting is paramount. You got to watch every step when you're doing your job. We get complacent when the job is done. And in this case, they're just leaving the roof. They could easily get hurt. If we talk about fire beneath us, I want to show you 2 views. I'm going to show you a thermal imaging camera view. And I'm going to show you the flashlight view. This is firefighters from a department we just trained sitting at the top of the stairs. Look how much heat is hitting them and how much convection currents and the speed of this is hitting them. They're sitting at the top of the stairs, fire's beneath them. It's moving up and out just like a chimney. And it's getting faster as it moves up. So we got velocity. That's not good. That's a lot of heat being transferred to them. We don't hang out in the stairwell, and we definitely don't hang out with the nozzle closed. Okay? So let's look at it from the actual attack position. One of the things you need to understand is I'm a big thermal imaging camera advocate, but a tick has terrible problems judging depth. So if I use a thermal imaging camera to judge stairs, I'm going to fall down the stairs. It can look like a washboard, as my friend and mentor, Chief Mitchum, says. So I want to look for the air intake. I want to look and see if that is stairs, because I'm noticing it spiraling fast down low, and I got a bunch of exhaust coming over my head. I'm going to use that light to identify and guide me down the stairs. I'm going to go down on my butt and sweep with my foot and sound and stay to the side of the stairs, which is where the strength is. So watch as I play the video. This is from Jay Bonifield again. He does some amazing work of a fast moving exhaust, low neutral plane, and fast air intake. And tell me if you can tell this is a basement stairs.
All right, buddy, do it. Let's get down.
Look at that. He's moving down the stairs. He's moving his stream. He's creating a pressure front in front of him. But what's over his head? Nasty turbulent smoke that wants to come back. If he shuts that nozzle down, all that heat and smoke's coming back over his head. So that's a proper way to make that push if you had to. But the point being is he used that light to see that. And we're using everything we got to identify those factors. We call that being intelligently aggressive. If you're the crew leader, the company officer, you're the designated adult. And whether you like it or not, your job is to watch out for your crew. And a part of that is directing them. How can you direct them if you can't see? Can you really do that effectively? As he said in the beginning, you can't mitigate the risk because you can't assess it. So using a focus beam light in this example, I can point where I want them to go. I told you about using the clock method to direct the stream, to tell them where I want to put things, to do things. I can show them with my camera and I can show them with my light. I've got two ways, not just one. When you're working in a very unforgiving environment, you want options. I don't just like one option because one option leaves me in trouble. So when I guide the stream, I can use lots of different things, but the thing that's most simplest to me is showing them on the camera, using the light to point to where I want them to do, put my hand on their shoulder, show them, and tell them in a clock methodology, hey, flow water from your 9 o'clock to 3 o'clock, see where my stream's hitting right there, focus right there until I tell you to stop. And by using high intensity focused light beams like this, it can be a tactical game changer. You can clearly see this is 25 feet away from me, that I'm able to see through that nasty smoke and point to the spot with both of these pictures where I want them to put the water. If you look right here in this actual image in the top one, you can see where the two intersect. He was dead on. It's like being a sniper and having a spotter. Those two work hand in hand. That's what you're doing. You can guide them to the fire. You can guide them in their search. You can take the light and say, that couch right there, search behind that couch. I can't see behind that. Use your light to your advantage. You're like a conductor. I showed you part of this video earlier, but I want you to pay attention to when we're directing the stream more specifically in these next two and how we use that light to our tactical advantage. You can actually see it banking off of the ceiling, hear the water dropping, hear it hitting the floor. He's dead on where I want him to put it. How about that one?
All right, tell him what you want to do.
He wants him to sweep the floor. Right there, you can see it dead on by using the light. The problem is a lot of times we forget we have the light, and every time we move, light's moving around all over the place. You got to put your hand on that light. So a crew leader or a company officer should not have a bunch of stuff in their hands other than the camera and the light, because they're like the orchestra conductor. Can a conductor conduct the orchestra if he doesn't have his two hands free to use those magical wands to do that? No. If I got a pike pole, a hose line, I can't do that. So I know not every staffing system allows that, but I'm just telling you, you need to use your hands to direct them by using your lights, your camera, and have a communication system to do that. You can clearly see in this example how they move that stream as well. See how powerful the light is, how far you can actually see?
Straight over your head first, baby. Straight up and feet it first.
You can actually see the droplets coming through the light beam as he's banking it off the ceiling. Like I said, we work in an unforgiving, dynamic, changing environment. You want the best of the best when you're in there, the best trained firefighters, and you want them to be able to do their job by giving them the best tools possible. So the other side of this is other tactics that we do. Vent inner search is a very critical one. You're getting in there. That's not when you want your flashlight to go dead. Like I said, you want to make sure all your tools are working. Take care of them, change your batteries, check them in the morning, clean things. But when this firefighter takes the window and opens up, they're going to be able to let that smoke lift. They'll be able to identify the same things, live fire and layout. What's the layout of the room? Where's the victim might be? My friend Thomas Anderson, instructor with me, says the tick doesn't always tell us or show us the victim, but it shows us where the victim might be. Same thing with your flashlight. You may see a crib. You may see a bed. You may see the door you need to isolate. You could always think about these things by using the light. Don't just jump in without scanning to see where you're going. You look both ways before you cross the street because you don't want to get hit by a truck. So don't just jump in there without looking. There's actual houses that have windows, and when you open them up, there's a 20-foot drop because you're in a foyer. It looks like you're on the second floor. You are a second-story foyer. You want to jump through that? Make sure you look, sound, do all the things you're taught to do, but use your light to your advantage. Firefighters are taught to hook a tool at the window to find their way back. I'm sorry, your tool doesn't glow in the dark. If I put my box light and leave it at the window pointing up, guess what I can see when I look back from the door, or if I go beyond the door and get disoriented, I can look back and see that light. I'm really willing to sacrifice a light so I can save my life or save someone else's life. Just make sure you do that and get used to it and have a system. Other uses of lights tactically, you got your fire investigators, emergency medical technicians, fire inspections. They need smaller, powerful lights that they can always carry with them. Why? Because you never know when you're going to need one. You're doing an inspection or crawling underneath a building, you need something that's smaller and brighter and adjustable. Don't count out the civilian side of your operations. Those guys and gals need lighting too. And matter of fact, if you've had to be stuck on homicide investigation or forensics or whatever it is, you found out that sometimes the police don't have the best lighting either because they called you and you're there to provide that lighting. And all the other incidents we get involved in, whether it's on the fire ground, motor vehicle accidents, EMS scenes, hazardous material incidents are a big one. Lost person searches. I don't know how many of those we go to every month where lighting would have benefited us if we had more of it. So we want to make sure we use every tool we got in the right context to provide the best environment for those responders to work. And the other side of this is don't have a one-sided view. You light up the front of the building, we still got to work on the back of the building. If you are that apparatus operator or the safety officer or somebody who sees the need, you're taught don't crawl past fire. If you see this as a problem, fix it. Tell somebody. I'm not telling you to freelance, but if you got the ability to put a light back there and light up two sides of the back side of the building, the Charlie Delta corner, to keep somebody from getting hurt or see the things you need to see, do it. It doesn't take that long because this is what the difference. One tripod light set up can illuminate the entire side of the building. And now we can work. It doesn't take us 60 to 90 seconds unless you're running a drop cord. And if you're working down an embankment on a vehicle extrication like this one upside down, how important is it for you to be able to see the patient, to see where you make your purchase points, make sure the vehicle is properly cribbed? What if you've got to jack this vehicle up? You're tripping over hydraulic lines, all the different things we can have down there. Your EMS equipment, you need that lighting. And then the individuals working inside to render patient care and aid need smaller lights. Like you can take the command helmet light, put it around your neck. You can have the scout light or a FoxFury BTS light, whatever light you use, have something in there so you can see. So when you're trying to take care of that patient, you're not doing it in the dark because they deserve us to be at our best. And when you're setting up landing zones, you should know that you should set them up within the proper dimensions that your organization requires you to, but they should be well lit. Ours requires we have to have two vehicles with intersecting headlights, and then we illuminate the scene for the ambulance to make sure they can get in and out of there. You don't want to walk out there in the dark and run your head into a tail rotor. That's game over. We want to make sure that everybody's on the same page with lighting and understand how critical it is. At the beginning of the first webinar, we gave you a lot of definitions. If you want more, I've made these little cheat sheets that explain lumens, IP, the ingress protection ratings, beam distance, lux, candela, all that stuff. because sometimes that can be confusing. We try to make it a little simpler and easier to understand. So if you want that, we've got that. And then I've got all the works cited where we pulled this from articles, research papers. If you want to go deeper in the weeds, please do. Please don't take my word as the gospel. Go investigate and learn as much as you can, especially some of the most recent work. It's really powerful, really educational. And at this point, I'm going to hand it over to Brother Chris Giles, who's going to tell you about some of the offers that FoxFury has that you may not be aware of. Chris?
Well, thank you, Andy. Excellent information. Half of it went over my head because I'm not a firefighter, but it's amazing what you bring to the table. So one thing I wanted to talk about before I talk about products that we have and all that is, one thing is we are starting to work with a grant specialist. And we're very excited about this because we know that a big problem that a lot of departments and agencies have is that they love the solutions that we're bringing. They love the products. They do everything, but they're like, we don't have the money. We don't have the funding. We don't have the budget. We can't do this. So we recognize this, and we're trying to find ways to help you get the money. So we're working with a grant specialist who has worked in this field for 20 years. He knows all the federal grants, the state grants, the private grants. So that's a biggie that a lot of people don't understand. But he can open some doors up to funding that a lot of people don't know is available. So if you're interested, get in touch with us. I put on this slide, we have Antonio Cugini. He is in charge of this program for FoxFury. And he can work with you and help you assess your needs, see what grants are available, and then work through the process. We won't write the grant for the department or the agency, but we'll walk you through it, figure out what works for you, and then increase your chances of getting the funding that you need. So that's a big thing that we're excited about on helping departments and agencies get the tools that they need. Going back one other slide, Andy had talked about the redundancy of lighting, which I think, once you've been in that position where your one tool fails, you realize, boy, I wish I had a backup. And this is something that we recognize, and we put together two of our most popular structure fighting lights. And they serve different purposes, as Andy spoke to, but they complement each other very nicely. So we're putting those together. We have a package, it's $186.99. And we think this is going to be a very popular combination for that. Now on to another small issue is that I would tell you to go to our website right now and order this, because we want to sell these to you. We're excited about that. But this week we have had an issue with our website, had some problems, and it is currently not working properly. But if you do go to shop.foxfury.com, that is going to be our temporary stopgap to access our whole website and all of our solutions, our articles, everything there. So hopefully we're going to have a new website up by, we'll say next week. But for now, go to shop.foxfury.com to look at all the things that we offer. So that was it on the grant opportunity that we're excited to launch, and our structure fire kit. I was trying to think if we had any questions for you, Andy. Let's see, I had one that came in talking about, what do you think are good recommended lumens for top, middle, and lower lights?
I think it really depends on your comfort level and your context. Obviously, the brighter the light when you're working in poor conditions. So the highest amount of lumens is great. But as you guys have taught me, be careful when it says up to a certain amount of lumens, because it could say up to, say, 500 lumens. But as the light performs and is used, the lumens degrade. So they're able to self-certify that. So make sure you go see one, maybe someone has one, and see how it performs. I like the brighter focused beam lumens. The BTS one is 700 lumens, if I remember correctly. Is that right, Chris? And that one,
Yes.
that one has been my favorite for doing like you're showing here, looking under beds, reading smoke. The command plus helmet lights. A helmet light that has a very bright lumen is great, but I would caution you buying one that doesn't have an adjustable setting, because the only complaint I had about mine was it was so bright that I had to set it down one notch and angle it up. Because when guys would walk to me, they'd say, Starnes, I'll talk to you, but you turn off that choo-choo light first because you're killing me. So make sure your light is adjusted for what you need. If that light's too bright and you're looking at a patient's eyes with it, they're not going to like you very much. So have adjustable lighting for the right context is my point. I love a super bright light for working in the fire. I like the helmet light because wherever I look, I have lighting. I just like the adjustable sides of it. I like the fact that you have a flood or a focused beam, and I like a smaller light for my everyday stuff. Like I showed the little scout lights on my radio strap at work. I'm constantly walking around the terminals at the airport, going in areas where there's not light, and I quickly turn that thing on. It's great for that. It's great for task lighting when I'm sitting in the command car. But the BTS or the right angle light, whatever you choose, and a helmet light, I think are a great combination. I think a box light is really underrated in what it could do. I think the problem with most box lights is they're not set up where you can use them or detach them from you fast enough. I personally like the seatbelt strap. You can go to an automotive parts store for about $3. You can buy a seatbelt strap and configure it to clip it to it, just like some of the other manufacturers have done, but you're only spending $3 on the strap. And if you have to hand that light off, you just put the button in front and hit it and hand it off. It's not an entanglement hazard. You need to leave it at the door. You're good. I purposely buy the ugliest color seatbelt I can buy because firefighters will steal anything except money. So if I have this pink or orange seatbelt, they won't take it. But if it's cool, it's black, and it's got all these logos on it, that thing will be gone in 15 minutes if you leave it at the station. That's just my opinion. But I do like the brightest lumens I could get on a right angle focused beam light, or if you're using one on your helmet on the side. Now, I'm not a big fan of things hanging off my helmet. I will tell you that, just because I'm clumsy enough. I don't need anything else causing me to get entangled and hung up. I've noticed that more firefighters get hung up in stuff. If you read RIT studies and collapse stuff, we get hung up in a lot of things. We are a walking or crawling entanglement hazard. So make sure whatever you're carrying is close to you and easily removable. That would be my caution. Does that answer it, or is that, do you have any other questions?
I think that was helpful. Yeah. Yeah. One thing that struck me as powerful is using the light as a guide for the stream. And that just seems like that could be really effective, especially with new guys who are, stressed about the situation and they're trying to make all these decisions, and the ability for somebody to guide them and say, aim it there. It probably relieves a lot of stress on where they're trying to put the stream and what they need to do. So it seems like a really effective use of a right angle light.
Yep, I love it.
Yeah.
I just would, I would buy stock and batteries, because the one thing I've learned through this is y'all have taught me too, Chris, is use the right batteries, change them out regularly, make sure you're using the same batteries. And if you've been sitting there a while, check for corrosion, because corrosion is usually our fault, and that voids your warranties on most lights. So use the right batteries, the proper ones, and change them often, because you want the utmost performance when you need it. You don't want to be in there doing venting or search and realize, man, I should have changed my batteries this morning. I really could have used that. No, that's not the time you want to figure that out. And you can buy decent batteries now for not spending a whole lot of money. Just make sure you do that. And a lot of departments do supply their firefighters with batteries. If you're blessed to have that, that's great. Just make sure, like Chris said, I like redundancy. I like having more than one flashlight, because my world, if I can break it, it'll get broke. So I need to have something so when I break one of them, that the other one's still working, hopefully. What else do you have, sir?
Oh, and you actually, you touched on a good point about batteries. Is AA batteries are kind of king of the hill on batteries. Departments will often, supply those over something that, like now they're seeing lithium batteries on the market, and they can be smaller, lighter, have a little bit more punch to them, but sometimes if they run out, they're hard to get. So that's one of the things to think about. Do you have access to batteries, and how much is it going to cost you to replace those batteries? And if you're so fortunate that your department will provide AA's, then it might be a good idea to find a lighting source that uses those and makes it easy and more cost effective on you. The other thing too is, depending on your work, can you get lights at some gas station in some random place if you're in a pinch, things like that. So those are good little things to think about.
Have any other questions?
I think we're pretty good. There's a topic about drones and lights. I don't know if we can touch on that briefly, but if you want to talk about the kind of the need for lights on a drone that's using thermal cameras, because that's a primary use of drones and Overwatch. And why would you think that lights might be necessary on a drone that's using a thermal? And
that's a great question. Here's the thing. Depending on the drone you use, obviously the further away we are, the less effective we are, depending on what type of camera you're using in regards to thermal or optical. Distance and resolution is a big deal. But when we're talking about lighting with the thermal, the majority of them are using FLIR cores, and they're using something called MSX. MSX is a combination of the digital camera and the thermal camera together. If you're in an environment at night and you're relying solely on thermal, you're not getting the benefit of the MSX. So if you have a bright floodlight adjacent to that or spotlight, you're going to get the benefit of the MSX and the benefit of the thermal. So you're getting optical and thermal together. I've seen the difference MSX makes, because you got to think about thermal. You can't see letters unless they're emanating heat. You can't see the actual smoke itself. You're seeing the heat through it. MSX does a lot of things through an algorithm. It's actually an AI type thing where it outlines the edges of things. It gives you edge definition. So, but it's not going to do that unless you have visible light. So having the light to do that is very powerful. Also, if you're searching for a lost person, you may be able to see them with the drone. What if the responders, you're walking through the woods, you want to try to let them hear the drone up in the sky? I got a big bright light. There it is right there, ladies and gentlemen. Go that way to the drone. You'll find the victim. It's a marker. It's a beacon, if you will. So there's lots of reasons, but including it with thermal, I can't stress that you need both enough. You need both. You don't want to just have one or the other. Like I teach in thermal imaging class, I don't want you to rely solely on the camera. I don't want you to rely solely on what you see. I want you to put as many pieces of the puzzle together and make an informed decision. But you can't do that if you don't have data. So I need that floodlight. I need that high resolution camera. And I need somebody who's educated enough to interpret the image correctly, which is probably the most key component of that equation. But definitely I would want a floodlight with it, to answer your question in a short summation.
Yeah, that's, I believe that you did do a webinar a couple, 3 months ago on drones and fire, and that is a topic that you can do a whole webinar series on, because it is becoming quite popular to utilize drones, and their use is very effective. It's opening the doors for fire.
They're not as costly as they used to be either. So
yeah. Well, it's becoming more standard, and regulations are making it easier to fly without having specialized COAs or one-off types of permitting.
Well, just like your lights too, Chris. LEDs used to be outrageous.
Yeah.
Now they're very affordable.
Yeah.
And they outperform halogens and everything else, and they last way longer.
Yeah.
So why wouldn't I want to buy something that uses less power, makes the battery last longer, gives me brighter working lumens and lux, and then it's going to cost me less money operational wise, because I'm going to buy it and it's going to last longer.
Absolutely.
It's a win-win. There's a lot more reasons, but in general, it's going to give me a better beam too for distance. If you compare them side by side in actual, beam distance length, the LED outperforms all of them. So,
oh yeah, definitely.
So why not?
And that's a little segue onto Dirk asked a question about how good are rechargeable batteries compared to standard AA's or any other size. The rechargeables will last longer than the AA's. I come from a photography and video background, so I use a lot of batteries in my cameras and all my devices and all that. So I've been using rechargeable batteries for a long time. The trick is that they need to be recharged, and you need to have backups that are recharged. So that requires a little bit more maintenance on the front end of being prepared to be able to, if you have a long shift, you got to have charged batteries there that you can access. And then I'm trying to think of like stability and heat. I don't know exactly how rechargeables stack up to alkaline batteries when extreme temperatures. Do you know anything about that?
Batteries in general don't like heat.
Yeah.
Alkalines pop open at 302 degrees Fahrenheit and
Okay.
then release potassium hydroxide on whoever's holding it. So that's not good. Lithium ion, on the other hand, they hold up a little bit better, but when they fail dramatically, and they cause big problems. If you want some interesting Google reading, look up the people who use vapes, electronic vaping.
Mm-hmm.
The ones that have had those explode in their pocket and the injuries that's resulted from that. When you have the lithium ion battery overheating and popping, and then a flammable fluid next to it. The difference is how well is that battery insulated to begin with, whether it's alkaline or lithium ion. You look at the housing on like your BTS light, the housing itself is pretty sufficient or strong, but then you also have a separate housing covering up the batteries, where most of them you open it up and it's just the batteries. So they're double insulated. So that's good. Think about that when you're what you're exposing this light to. There's a lot of firefighters I know that would take a green line from their yard and go into Satan's living room and fight fire. They don't need a cheap flashlight that has batteries just stuck in there. They want something that's well insulated and durable. Plus water ingress, or getting in there. Even though all the lights say they're waterproof or IP67, or they're dust and water intrusion safe, if we can get water in it, we will. And the way we'll do it is we'll drop it, forget about it, and it'll be in there longer than it's supposed to. So in my opinion, I like the lithium ion rechargeable batteries better, but it really comes down to the care of that, because I've seen more lithium ion batteries fail because of firefighters don't care for them right. They charge them wrong. They don't clean the contacts. They shove it back in the charger dirty, all kind of different reasons. But here's the deal though, if it's your light, you're probably going to take care of it better. I've seen firefighters treat their department lights pretty bad, but if that's my light that I had to spend my money on, I'm probably going to take care of that light a little bit better. And I want the lithium ion batteries just for the length of use. Alkaline don't last, in my opinion, as long as a lithium ion does. That's just mine. I think it's worth the initial investment if you're going to care for it and keep them up. That's just my opinion.
Yeah. And that's what we see on repairs and maintenance, is that a lot of the problems that we see come from, say, a light that got thrown in a bag or a locker for a long period of time, and batteries just sat and corroded. Or like you mentioned before, mixing batteries of different ages or strengths or different types, which is some putting an alkaline and a rechargeable in the same device, that just leads to problems. So little things like maintenance and cleaning terminals and switching out batteries and making sure that it's dry before we store it, those are all great things to do that prolong the life of the light.
Got to take care of it. That's the bottom line.
And it'll take care of you.
That's right.
Yep.
What else? Yeah.
So yeah, I think John had a question about rechargeable batteries for Nomad lights that are older. John, we're happy to, we make the batteries. It's something you can actually replace yourself, or if you don't want to, you can send them in and we can do the replacement ourselves. But the replacement is quite easy. It takes like 20 minutes per light to switch them out. So that's a possibility, and I'm happy to get you more information about that. But yeah, I think that's kind of covering all the questions for now. If anyone has anything else, feel free to contact us or Andy to get more information. Talking about the drones, I think there's even more potential for more webinars and education in the future. So that's exciting. And then Andy, you want to give your information here?
Yeah, my email's at the top of this slide. They can still see that, right, Chris?
Yes.
Okay. My website's there below the logo. That's my personal cell phone number. You can text me or call me if you have a question. Just don't do so after 10 p.m. I'll get in trouble. If you're looking for more information on what we do, you can look up Instructor Andy Starnes on Facebook. If you're interested in thermal imaging and all the classes we offer, go to Facebook and type in Tactical Thermal Imaging. That's a private group. It's all that stuff. I don't allow any fancy spam or none of that stuff. It's just that topic. We have about 800 files in there. Our YouTube channel is Insight Training LLC. There's about 600 videos on there. I'm pretty sure FoxFury is going to share this. Is that correct on your page, or let me put it on YouTube, however you want, Chris? I'm not sure.
Yeah. So we will, like I said, this has been recorded, and we will post a copy of this whole webinar online. It'll be available. We'll send out a email to everyone who registered to access that information, and we'll put all of Andy's contact information, the grant assistance information, and then if you have any sales inquiries, we're happy to take those as well.
Thank you all so much for the opportunity and taking your time away to listen to us today.
All right, thank you, and appreciate all the insight. All right, see you guys.